Madam Director Bryanskaya, respected members of the Vorontsov Institute of Organic Chemistry in Novosibirsk, ladies and gentlemen, today is a good day for science. First of all, I'd like to thank you for the invitation to talk to you today. I really appreciate the opportunity to reminisce about the past and the present. Today, you celebrate the 65th anniversary of your institute. As part of the global science community, you have been undertaking forefront research for decades, and perhaps even more importantly, you have provided training to generations of young researchers. But there's another good reason to celebrate. This year marks the 25th anniversary of the collaboration between your institute and the University of Bremen. Our joint research efforts yielded in not less than 35 joint publications. This one is the first one. It's a ChemCom paper from 1998. It is about the synthesis of sulfur-nitrogen anions. These anions were obtained by the reaction of trimethylsilyl aryl sulfur diamides, which were reacted with TUS fluoride as a fluorine source. So two compounds were obtained and they were fully characterized, and they showed that there is significant delocalization of the negative charge across this linkage here. You can see this paper has three authors. First one is Professor Andrei Tsibarev, which of course don't have to introduce to you. The second one is Dr. Enno Lorck, who is still a crystallographer in my group. And the third author is Professor Rüdiger Mewes, who is the founder of the collaboration from Bremen side. I would like to take a minute to introduce Rüdiger to those of you who don't know him. So Rüdiger Mewes was born in 1942 in a small town in Pommern, which now belongs to Poland. After the war, he came as a refugee to the northwest of Germany, where he received his early education. He started, after finishing high school, he started studying chemistry at the University of Göttingen, and he received his PhD in 1970 under the supervision of the famous professor Oskar Glemser. He is famous for his pioneering work in fluorine chemistry. So in 1971, he undertook a postdoctorate at the University of California in Berkeley, United States. And his advisor was the not less famous Professor Neil Bartlett, the founder of Noble Gas Chemistry. Then he returned to the University of Göttingen to undertake his habilitation, which he finished in 1976. In 1981, he received a call from the University of Bremen, where he spent all of his academic career. The year 2006 was a very important year for Rüdiger Mewes because it marked the award of the Doctor Honoris Causa from your institute. In 2009, Rüdiger retired from the University of Bremen, and I had the honor and the luck to succeed him in his laboratory. Sadly, in 2019, Rüdiger passed away in his home in Fischerhude near Bremen. The photograph shows Rüdiger Mewes with some of the artifacts or early apparatus he used in the laboratory from Oskar Glemser and Neil Bartlett. This on the right-hand side is a picture of the Institute of Chemistry we're working right now. So the building is about 25 years old, and Rüdiger was one of the persons who planned the institute. Okay, this gentleman I really don't have to introduce to you, but I thought I'd show you where Andrei stays when he visits Bremen. So I received this photo from him recently, so I assume I have the permission to show this with you. This is, of course, really Andrei in younger years. So when he visits Bremen, he stays in the university's guest house, which is situated on this small island in the Weser River. So it's not the most spectacular building, you agree, but on the other hand, when he looks out of the window, he has really the most spectacular view in the whole of Bremen. So when he looks through his window, he sees this town line or the water line of Bremen with the cathedral and the boats in the harbor. And this is really the area where people go out to have fun. On the other side of this little island is the Beck's Brewery, which is famous for its beer. And as you can tell from the photograph, and Andre is also enjoying a glass of beer, and he even received T-shirts from the Beck's Brewery from somewhere. So the next publication is a paper in European Journal of Inorganic Chemistry from 2012. And it has been cited 40 times already. And it's synthetically very challenging work that has been carried out by the two Nikolais, Nikolai Semenov and Nikolai Pushkorevsky, who are really excellent experimentalists. So they have prepared this cyanotelluroddiazole, starting from this precursor and tellurium tetrachloride or bromide in the presence of pyridine or triethylamine as acid scavengers. So with triethylamine, they obtained this heterocycle without any additional halides, but in the presence of pyridine, such donor acceptor complexes were obtained, which show that the telluroddiazole possesses some degree of Lewis acidity. So this idea we wanted to pursue further by the reaction with different anions, such as fluorine, iodine, or even phenyl sulfur or thiolates. And this paper is the most successful one so far. It has been cited 55 times. It was a paper in organometallic chemistry from 2014. Yeah, so your institute is, of course, renowned for the preparation of radicals and radical anion salts. And so it doesn't come as a surprise that this research was also pursued. Here we studied the preparation of benzo-chalcogena-diazoles and their radical anion salts. Here's an example for selenium, single electron reduction with potassium graphite gave rise to the preparation or formation of this radical anion that was isolated as crown ether salt, or in the absence of a crown ether, this was obtained as solvated potassium salt. For tellurium, there's evidence to suggest that a similar radical anion is formed. However, that proved to be unstable, and even under an inert condition, this formed this very interesting doubly charged anion, which contains a chain of 3 tellurium atoms. So, as I said, this is synthetically very challenging chemistry, and even in traces of oxygens, usually these compounds decompose. Here we got an example where an interesting product was obtained. So in the presence of oxygen, this compound further reacts and gives this dinuclear species, which has 1, 2, 3, 4, 5, 6 tellurium atoms. So this paper was published in 2019 in Chemistry European Journal. And of course, good results want to be presented on conferences. And it happens to be that there was a conference relevant to our chemistry in 2019. It was the International Conference on the Chemistry of Selenium and Tellurium that took place in the Hotel Resort Flamingo in the south of Sardinia in Italy. And you see on this slide the EPR spectra of the compounds of the radical anions we just presented in the paper I've shown you before. And here, a little bit in the dark, we see Professor Zibarev, who is presenting those results. So this was at the excursion of the conference. There are some historic sites of the Romans, and this was the very nice and pleasant conference building in that resort. After a hard day's work of presenting scientific results, of course, there's also time to celebrate. And these are pictures taken at the banquet dinner, which show Andrei with his lovely wife, Ina Tsibareva. And here on the left-hand side, we got Nikolai Semenov. As I said, we call him Klaus because he introduced himself like that. There were some folklore dances in the evening and a nice sunset, and I used to remember this very pleasant day in the presence of friends. So this is a paper from 2015, a chemical science paper that originates from my lab. This is about the preparation and oxidation of diaryl dichalcogenides that are stabilized by bulky metaterphenyl substituents, and the radical or the one electron oxidation gives rise to radical cations. This time we studied the oxidation beforehand using sulfur voltammetry, and you can tell clearly these are textbook examples of reversible cyclovoltograms, and you can tell that the tellurium can be easier, or the tellurium compound can be oxidized easier than the selenium compound, than the sulfur compounds. And we got crystal structures for all of these compounds. What you can tell, this is a picture from the spin density. It's the radical has pi character, and it is delocalized over the two chalcogen centers. This is a related work, or this is related work from earlier this year. It's a chemistry paper. This time we investigated compounds that have only one chalcogen, but two of the metaterphenyl substituents. We first, again, looked at the cyclovoltograms and the spectroelectrochemistry. This time it turned out that only the tellurium compound can be oxidized to give a reasonable product. For the single electron oxidation, we use xenon diferrite in the presence of a potassium salt of a weakly coordinating perfluorinated BAF anion. So this procedure gave rise to a radical cation where the center is not delocalized anymore, but it's nicely shielded. It's this blue compound that has been characterized with the help of EPR spectroscopy. That was really challenging. Nonetheless, the spin density is again situated on the tellurium, and it has some pi character. So this paper, or this experimental work, was carried out about a time, or at the time, when Leonid Shundrin and Danila Otsinov visited our lab. And from time to time, we take group photos, and that was just happened to be at the time when these two visitors are around. So this is a picture of my group with our two pleasant guests from Novosibirsk. So I like to use the time now to again mention those nice people from Novosibirsk who visit Bremen on different occasions. And of course, Andrei Tsibarev and Leonid Shundrin were frequent visitors to our laboratory, but we also hosted Nikolai Pushkarevsky and Nikolai Semenov as well as Lena Shulanova and Danila Otsinov. So we are really happy to have you guys here, and we hope that we can continue our collaboration in the near future, perhaps with a new generation of young researchers. So that young researchers can make really an impact shows the next paper I want to show. This is a crystal engineering com paper from earlier this year that is published by Elena Shulanova as a sole author. So she investigated charge transfer complexes between chalcodiazoles and tetrathiofulvarenes, such as depicted here. They form layered structures, and you can say that there is some interaction between those rings. This is the NCI. NCI stands for the non-covalent bond interaction indicator, and it's indicative of van der Waals type interactions. Here, Elena has done a Hirschfeld surface analysis, which gives details about the kind of interactions that occur between the donor and the acceptor. And it also gives energy values that are associated with the complex formation. So this paper is a nice example, I guess, to show that the new generation of chemists can also make a really strong impact and give a modern spin into science. So now we come to a point on March 21, where I received a very pleasant from your Madam Director. So this letter made its way all the way from Novosibirsk to Bremen, more than 3,200 kilometers, if I'm not mistaken. And in this letter, I was informed that I was awarded the Doctor Honoris Causa from your institute. And this makes me really happy. And I like to use this chance really to express my gratitude to Professor Andrei Tsibarev and Professor Leonid Chundrin for the nomination. And of course, also, I like to extend my gratitude to the Academic Council who has elected me. So thank you very, very much for this nice gesture. It's much appreciated. And I accept this award in recognition of the contributions of past and present group members who really made this cooperation work. Thank you so much. So this brings me nearly to an end. So I salute you for the 65th anniversary of your institute. This falls together with the 25th anniversary of our really fruitful collaboration we have. So on the left-hand side, this shows a statue of the Bremen town musicians that comes from a German fairy tale. And the story, I don't want to repeat the story here, but it's really about cooperation. These animals had to work together to fight evil, and perhaps this is also a nice symbol of our collaboration. We have to work together, or we work together best to achieve the best scientific results. So I like to use the chance once again to congratulate you and wish you best of luck for the future. Ladies and gentlemen, I like to close my talk with a quote from the famous French scientist Louis Pasteur. He said, "Science knows no country, because knowledge belongs to humanity, and it is the torch which illuminates the world." These are indeed words of wisdom. Thank you very much.